Welcome to this video. I'm Physics and today we are going to be going over parallel circuits. First of all, what is a parallel circuit? A parallel circuit is the way of connecting components on separate branches, making the current share and take different routes between them. So, charge conservation in a parallel circuit. The principle of charge conservation states that the total electric charge stays the same in a closed system. This leads on to Kirchhoff's first law, where the total current flowing into the junction is the same as the total current flowing out of the junction. So as a result, in a parallel circuit, the sum of all the currents in each parallel set of branches is equal to the total current. Energy conservation. The principle of energy conservation states that energy cannot be created or destroyed but transferred, so the total energy in a closed circuit stays the same. This and the charge conservation leads on to Kirchhoff's second law, which states the sum of all voltages in a series circuit is equal to the battery voltage, or the sum of all the voltages in a loop is equal to 0. This leads to the potential difference of each branch being the same as in each branch being the same in a parallel circuit. A remembering hack, SCPV, where S equals series, C equals current, P equals parallel, and V equals voltage. So SC states that in a series circuit, the current is going to be the same everywhere, and in a parallel circuit, the voltage is going to be the same everywhere. So combining resistances. The formula for combining resistances in a parallel circuit is 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3 plus how many of our resistors there are. So now we are going to be going on to the GCSE example exam style question, where it states R has a resistance of 11 ohms. Calculate the potential difference across R. So we can see that we can write SCPV here, and we can see that as it's a parallel circuit, the voltage is going to be the same and the current is going to be different. This can be seen through as the total current being 0.6, and as it goes into R through this branch, it changes to 0.4. And so the current going through this branch will be 0.2 amps going through this one. So calculate the potential difference of R. So we're given the current, which is over here, and we're given the resistance of R, which is over here. So we just need to use V equals IR, and that will give us 0.4 multiplied by 11. So when we do that, we'll get 4.4 volts, and that's the answer. So now we are going to be going on to the A-level example exam style question, where it states, use the principle of conservation of charge to show that the total resistance RT of the three resistors can be found using the expression as seen over here. So the conservation of charge, it can be written out as QT equals Q1 plus Q2 plus Q3. And as you can write it over time, we'll just write all of it over time, equals Q1 T plus Q2 T plus Q3 over T. And as Q over T equals I, we can write it as IT equals I1 plus I2 as plus I3 due to SCPV, which states that the voltage in a parallel circuit is going to be the same, but through different branches, the current is going to be different, which can be seen through I1, I2, and I3. So we can also write this as using V equals IR. We can write this as, and we rearrange for I, so V over R equals I. We can write it as V over RT equals V over R1 plus V over R2 plus V over R3. And as all the voltages are the same, we'll cancel them out. And so we're just going to be left with 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. And that's the answer. So thank you for watching this video. I hope you have learned something from this video, and it would be really appreciated if you could share this video and subscribe. Have a fantastic day.